Hi folks, we're going to take a look at number 13 from page 179. This is a pretty typical type of question where they give us some information about a function, in this case here a polynomial function, and they want us to determine the missing components, which in this case here are all the coefficients. So because it's a cubic polynomial, okay, they're looking for all the coefficients, so 4 of them in all, and this is why they have to give us 4 pieces of information. Now at first glance this might look like 2 pieces of information, but it's actually 4. Because when it says it's got a local max at 2, 4, well, first of all, you have to figure there's the point 2, 4, which is on this function. But since there's a local max there, well, we know that local extrema can only occur at critical points. And since this is a polynomial, so it's not going to have any derivatives that don't exist, the only place that can happen is if the derivative at 2 is equal to 0. And similar here. If it's got a local min at 0, 0, means 0, 0 is on the curve. And since it's a polynomial and it's got a local extremum there, the derivative must be 0 at x equals 0. Okay, so 4 pieces of information that we're going to have to use to determine these coefficients. Okay, so I think the easiest one to start is 0, 0. Okay, because we know that g at 0 is equal to 0. But when I plug in g at 0 here, all these terms disappear except for d. So that gives us d equals 0. So right off the bat, we were able to eliminate one of our coefficients or determine its value. So we know that d is equal to 0. Okay, now I could stick in 2 and then 4 into the x and y values, but the nice thing about finding the derivative, okay, is that the derivative is going to get rid of certain components. It's actually going to simplify the function. It's going to take this cubic and turn it into a quadratic. So I started with g at 0 because I knew it was going to be an easy one. It was just going to be the y-intercept. So let me go now and find the derivative here. So g prime at x is equal to, so again, a, b, c, and d are just constants. So this is just going to be 3ax squared plus derivative x squared is just 2x, so 2bx. Derivative of x is just 1, so just plus c. And d, well, derivative of d is 0, but it was 0 anyways, so that wouldn't have made a difference. Okay, so now I've got my derivative function here. And I think I'm going to start with 0, 0 again. So remember, there's a local extreme at 0, 0. That means that g prime at 0 must be equal to 0, too. Okay, so what is g prime at 0? Well, again, the first 2 terms just disappear, and the only thing I'm left with is c. So lo and behold, there we go. We've got the value for c. So quite easily we're able to get the first 2 pieces of information. Okay, so now the only thing I'm left with is a and b, and I've got 2 pieces of information that I have not used yet. Okay, I haven't used the fact that 2, 4 is on the function, and I haven't used that there's a local extremum at x equals 2. So let's go to that one. Okay, so I know that g prime at 2 also needs to be equal to 0 since there's an extremum there. And what is g prime at 2? Okay, so here 2 squared is 4 times 3 is 12, so we've got 12a. 2 times 2 is 4, so we've got plus 4b. Okay, c was equal to 0, so that's gone. And this expression here has to be equal to 0. So here's my first equation with a and b. And now let's see if I can find a second equation with a and b. So now I'm going to actually input x equals 2 and y equals 4 into the original function. Okay, so here when y is 4, the x value is equal to 2, so 2 cubed is 8, so we have 8a. 2 squared is 4 plus 4b. Okay, and both c and d are equal to 0, so those terms are gone. And so here I've got a second equation. In fact, I can even simplify this here. Divide both sides by 4, so I've got 1 equals 2a plus b. Okay, and there's my second equation. Okay, so now I'm going to solve this system of equations. So here, in fact, we can simplify this one here again. So again, divide both sides by 4. So I've got 3a plus b is equal to 0. I'll put equation 2 underneath. I've got 2a plus b is equal to 1. And now we'll subtract these 2 equations. So 3a minus 2a is just a. b minus b is 0. So a is just equal to 0 minus 1, negative 1. So there's my third coefficient. And now I can use any one of these equations to solve for b. So I'll use this here. Okay, so for number 2, I have 1 equals 2 times a, which is negative 1, plus b. So b is just equal to 1 plus 2 is 3. And there we go. So just to recap. Okay, we have 4 unknowns that we're solving for, so we need 4 pieces of information. Each of these 2 points contain 2 pieces of information. One, the actual points on the curve, and the fact that they were local extrema. We knew that the derivatives had to be 0 at those x values. The other thing to keep in mind is anytime you've got a point that has some zeros, that's often a good one to start working with. Okay, that's it for this one.